vector at the maximum height in the three problems, in the three cases. What can you know? What do you see? At the maximum height, what do you see in the velocity vector? How it's pointing? There is no y component. It's pointing horizontally. What is the meaning that it's pointing horizontally at the maximum height? What will be Vy? Like in free fall? No acceleration. No, there is acceleration, but not on the x direction. So what is the meaning of that? That there is no component of the velocity vector y component. What is Vy? 0. So Vy is 0 at the maximum height, at only the y component. The x component is not 0. So I haven't seen that when you throw an object, get frozen at the maximum height. So it doesn't stop. It keeps going, but it keeps going along x, not along y. So Vy is 0 at y max. This is another thing you need to note. And the lowest level in the problem, the position, what is the lowest level in the problem? What position? Vertical. How much? At the lowest level in the problem, 0. There is no y position. Y final, here how much?
0.
How much is here?
It's still 0.
And how much is here?
Is it 0?
0. But at the lowest level. So, always at the lowest level, that will be your 0 position. Okay? Any question with the theory of projectile motion? Now we will concentrate on solving problems. All right. Let me just show you for that. All right. So what I explain here, okay. So what I explain here, okay. So here we have the object, and we can find or can calculate all the trajectory of this projectile, since if we know kinematics, if we know the equations and the theory that I show you there. So all these calculations are probable. Put it into the computer, and the computer do the calculation at every single time. So if I just fire, you can see the trajectory of the object. So what we will do here is to do this calculation, but manually, instead of with the computer. So if I change the speed, you can see if I change to 50 or to 20, which is here, and if I change this to 37, and we fire, this is what we get. 2.46 seconds, right? For the time. And for the position, the position here is slightly before 50 meters, correct? The maximum height is very small value, but we can calculate, okay? So this is, if we increase to 40 and 37, we fire, we can see. Okay, let's use 40, for instance. So, to do our calculation, so 40, you know that will be, the time will be 4.91 seconds. Now we will do the calculation analytically. So, all right, so let's let's start. We will want to find the time, which was 4.91. Let's use the same value. So let's say, for instance, I will start with this type of motion. So if this is this type of motion, before that, let me start with the first one, with the horizontal one. Before that one. So with the horizontal one, we need to know, number one, let's say, if we go to here, the study guide, I didn't put too many projectile motion here, so probably I have to bring another paper with more questions. Because you only have 2 questions on projectile motion, that's not too much to practice. So I have to give an additional one just to practice projectile motion with 4 or 5 questions more on projectile motion. All right, let's say, for instance, an object or a motorcycle leaves the cliff top from here, so to here. Let's say, for instance, that this is a 50 meter YO. So from the height of the cliff, which is 50 meter height, 50 meter height, and lands at a distance which is 90 meter here, where the cameras are. So he's a movie driver. He's a movie stunt driver there and doing a movie, and he and want to go to here, 90 meters below. So he goes horizontally. So he leaves the cliff top horizontally, this type of motion. So label problem 1, the horizontal one. The keyword there will say horizontally. So with that given, the question is A, find the time of flight. B, find what will be the velocity initial. The velocity with what the driver leave the cliff top, which is B initial. C, find B final. B final.